When you talk about climate change in history, the goal is just to take a look at trends, things that happened in the past that may have been influenced a little bit about what the climate was going on at the time. That means basically that this presentation could go in an earth science class, or it could go in a world history class, or it could even go in an economics class. To understand the role of climate in history, we need at least a basic understanding of the system that makes tropical deserts, the process that could make a desert move, and the systems that cause natural climate cycles. A climate map has got an awful lot of information on it. It's really hard to remember it if you just take a look at that map. So let's declutter it and focus on just the major deserts of the world. How would you describe the locations of these dry climates? And the fact is, it's a whole lot easier to understand and to explain the geographic pattern if you understand what causes it. So let's go back to the basic question, what causes a tropical desert? Rain near the equator. How? This is how it works. I've turned the globe sideways so that the equator is up. Sun-heated air at the equator, remember the sun's nearly overhead nearly every day. It rises and makes rain near the equator, and that air has to come down somewhere. And it's not going to come right back down at the equator because it keeps getting pushed up. Given the present facts about the Earth, how big it is, the rotation speed, distance from the sun, thickness of the atmosphere, all that kind of stuff, down is close to the tropic lines. And that's just a fact. If the atmosphere were thicker, it would happen at a different place. And in fact, when the atmosphere changes, down does change. So it goes up near the equator, it comes down near 30 degrees, near the tropic lines, about a third of the way toward the poles. And where that air comes down, it makes a desert, except on the east sides of the continents, where the combination of trade winds, warm ocean, and hurricanes make a little bit more rain. But even parts of Florida tend to be very dry for some times of the year. So let's make a generalization about the location of deserts. We'll need that in order to understand what happens when they might move. Generalization is deserts actually start on the tropic line about 1,000 miles west of each continent because there's a cold ocean current out over there. It tends to reinforce the downward movement. And then they spread out to be about 20 degrees latitude, or 700 and some miles north-south, when they reach the continent there. And they stop when they hit some mountains, which means in South America, they'll stop real close to the coast. In Africa, they go about halfway across till they hit the Drakensberg. In Australia, the desert stretches all the way across to the dividing range way at the east edge. And there aren't any major mountain ranges in North Africa or Arabia, so the desert keeps stretching until it gets all the way to India. In addition to those tropical deserts, we've got another family of deserts made by a completely different process. These are the rain shadow deserts that are east of the mountains in the mid-latitudes. So there's a rain shadow down here in Patagonia in South America. There's no rain shadow desert in Australia or Africa because the continent just doesn't reach far enough south. So how does this relate to history? Remember how these deserts are made. Air rising near the equator is pushed down near the tropic lines. Recent research clearly shows that if the Earth gets a few degrees warmer, it pushes air higher above the equator and it comes down farther away from the equator. Now, I'm not going to try to explain all the science about it. It isn't what you'd call easily accessible for people that have ordinary grasp of mathematics. It's pretty complicated. But the equations make very specific predictions. They basically say that subsiding air, the downward air movement, is going to be farther away from the equator when warmer air makes storms stronger near the equator. And the website that we'll show you at the end of this presentation has activity pages, notes. You could duplicate these and give them to your students for them to mark as we watch the rest of this. So to repeat, when global temperature is a little high, the desert maker is pushed a little further away from the equator. What places are likely to be hurt when this happens? And the most dramatic place is going to be right around the Mediterranean, in southern Spain, Greece, southern Italy, North Africa. But it'll also affect places in Southern California and in the same areas in the Southern Hemisphere, just a little farther away from the equator than where the deserts are. And all of these areas have had serious droughts over the last 15 to 20 years. Cape Town has been declared itself a national disaster. Chile has the worst drought on record. Australia's drought is worsening. Drought in Spain reaches exceptional levels. California has 1 year. Everything from the Los Angeles Times to Fox News is busy reporting that there are droughts in precisely those places you would expect them if the desert was being pushed a little further away from the equator. And located just north of the Great Sahara of Africa, the Mediterranean is especially vulnerable. And you can find a handful of articles that show how that affected a place in the Eastern Mediterranean like Syria. This is a timeline of events. In Syria, the big drought started about 2005. By 2010, Syria had more than 1.5 million climate refugees. These were people that were pushed off their farms by this prolonged drought. And that happened before ISIS came along. And in fact, the refugee camps became prime recruiting grounds for ISIS. And now we're starting to find archaeological evidence that says exactly the same thing has happened several times in the past, back in when Sumer and Akkad and Babylon, that they were being affected by these cyclical droughts. So the summary of part one: when the global temperature is high, the desert maker is pushed away from the equator. This hurts places about 35 degrees of latitude toward the west coast. It can help places about 15 degrees of latitude. Places like Mesoamerica, like India, like the Peruvian areas, Nazca and Mocha, some of these pre-Inca civilizations. And it can help the northern and highland areas that might get warm enough for more profitable farming, like where the Vikings are or where the Mongols were. Now, contrary-wise, when global average temperature is a little low, the desert moves toward the equator. That can help places 35 degrees of latitude and hurt places about 15 degrees. Plus, it's going to hurt places up north that have plenty of rain but are just generally colder. And we now have a fairly good record of global temperature for the last 10,000 years. This simple graph is based on thousands of tree rings, cave records, lake sediments, other measures of past temperatures. The Giants website that I'll show at the end of the presentation has this graph that you could print and hand out to students, and they can follow along while we just put a few key events on the graph. Glaciers were melting about 9,000 years ago. Hunters thrived during that time. You know, the places that were warm enough and they were becoming more productive. When the climate started to turn back to a little bit cooler, people had kind of killed off most of the big dumb animals by this time. That's a whole nother lesson. And agriculture started in several places around the world. The Central Asian nomads, again, we've got another lesson about that, were during a very warm time about 4,500 years ago. Egypt and Mesopotamia down during a more cool time when the desert moved further south. The Indus Valley did pretty well when it was warmer, and the Hittites ruled during a pretty cold time, and the desert moved south, and Turkey was a little bit rainier. The Sea People came and ended what's called the early Bronze Age civilization about 1,200 years ago. Classical Greece was during an exceptionally cool time. Rome expanded north into Europe when Europe got warmer, and the barbarians invaded Rome when Europe got colder, and they started to starve up that way. The Vikings and the Mongols did pretty well when things were warmer in theirs. The Ming Dynasty collapsed during an exceptionally cold time. In other words, there's a long string of events that are directly related to the north-south movement of these deserts. That's the science behind a very simple fact. Climate changes had a lot of impact on history. Global warming is bad for some places, and it's good for others. Now, you could stop this PowerPoint right now and make the rest of this a separate lesson, but these things go together because this is going to raise a question. Is this happening today? To start with one important fact, all of these cycles we had in the past, they are natural cycles. Earth's orbit is not a perfect circle. It's a, say this fast, a wobbly tilt on a wobbly oval. And as a result, you can find the details on a lot of websites. Keywords Earth orbit, and you'll get a handful of websites. It's pretty complicated, but we know a lot about temperatures from ice cores and things like that. Incoming solar radiation has varied a lot over time. There's roughly a high point about every 100,000 years. And carbon dioxide and temperature also reach a peak roughly every 100,000 years. If we put these three graphs together, you could see that the high points of solar radiation, they are connected. Solar energy, temperature, carbon dioxide are obviously related, but it's complicated. Our website has got a graph activity that you can use to help students discover a really important fact. A key part of this global climate system is now way out of line with the natural cycles that have occurred in the past. Ask the students just to describe this graph in their own words and to think about what the consequences might be. Here's a really useful analogy. Suppose your heart rate was between 70 and 130 beats per minute for years, and then suddenly jumped up to 200. If you've got any sense, you're going to want to know why and if there are any consequences of that. I'd like to trace just one consequence. Again, this is a whole nother story, another chapter of the story that you could have on a different day. Let's just trace one consequence of this increase in carbon dioxide at a time when solar energy is actually decreasing. In other words, the world ought to be getting colder right now, but it's not. It's getting warmer. The deserts are moving north. California has a drought. We've got fires going on. And yet we get these cold winters and all the rain and snow that California got in 2022. Yeah, this is likely to be politically controversial. So be it. I am talking about the science here. The science is that the observed temperature in the Pacific Ocean, look at that, that's just Africa, Europe, Eurasia there. The temperature off the Philippines was record warmth in January to October of 2013. So we've got record warm temperatures here. When a hurricane crossed that warm water, it got to be the strongest hurricane ever measured on the Philippine Islands. Enormous amount of energy that was still in that tropical storm carried up toward the North Pole. Um, the effect of carrying all of that warm air up toward the pole was to push some of the cold air away from the pole. And that cold air came flying down directly toward Michigan, and Michigan wound up with some of the coldest temperatures that they'd had. The science is solid, but it's complicated. It's especially complicated for somebody who either can't or won't try to follow a logical chain of cause and effect that has more than one or two steps. In other words, something too big to fit on a bumper sticker. We give you students a possible teacher worksheet like this where they put these things in order here. But storms are rising higher near the equator. The effect is to make the trade winds stronger, and they push more water over toward the west. That water gets warm, and it makes the hurricane strong over the Philippines. As those air masses move north, they carry a lot of latent heat, evaporated water with them. And when they get to the Arctic Ocean, they help make the ice melt a little bit more. With more melting ice in the Arctic and warmer air, permafrost is likely to be melting, and this creates bigger loops in the jet stream in the mid-latitude. And the effect of that is to push some cold air all the way down to Texas. In other words, if you want to understand why it's cold in Texas, you have to trace an 8-step causal chain that starts at the equator, involves this desert movement, and some things going on in the Arctic. And when Texas had that cold temperature, and it's shown on this map from 2014, before you draw a conclusion about the whole world, you ought to take a look at the map of the whole world. That there were indeed 15 areas of the world that were colder than average or had record cold temperatures. But there were 742 areas that had warmer than average or record warm temperatures. As one blogger asked at that time, can global warming be real if it's unusually cold in Michigan? And in about 50 languages around the world, people were shouting, yeah, it sure can. In 2015, Michigan was slightly above normal, but look at it, 100 areas have record high temperatures. In 2016, most of the world was above average, but a small cold area in the Pacific caused a wet winter in California. 2017 and 2018, it was much warmer than average almost everywhere except over near Iceland. 2019 and 2020, it was also warmer, but La Nina, the other half of the El Nino cycle, had made more ocean water a little bit colder off of South America. And that led to really cold temperatures in the Pacific in 2022, while the rest of the world was way above average. And that ocean cooling led to the rain and snow and flooding that we observed in California, which coincidentally was one of the very few cold areas in the entire world in 2023. So the big point for today is global climate change is not just about temperature. It's about deserts and how deserts can move. As the global temperature goes up, the desert maker is pushed away from the equator, and it is possible to predict the places that could be hurt. These are the places where climate change had the most impact on history. Time of the Sea Peoples, time of the Mongols, time of the Vikings, the collapse of the Ming Dynasty, and the droughts in California now. And north of the huge Sahara, the Mediterranean is uniquely vulnerable to a moving desert. In the package of handouts on the website is a bibliography about movable deserts. The researchers are based all over the world, including 2 labs and 3 universities in the United States. And if you want a quick summary of it, go to the Michigan Science Teachers Journal. It's on the web. You can download it free, spring 2016, and there's an article that's just called The Movable Deserts. The big point restated, global climate change is not just about temperature. It's about deserts and warm water and hurricanes and snow in Michigan and floods in California, drought in Syria and barbarian invasions in Rome and the fall of the Ming and the emergence of Timbuktu and the plagues that swept across Europe. If you want a way to put this together, again, go to the website, find the World Geohistogram, and there is an activity where you basically would take the warm period and just color it pink for warm. And the cold periods you could color blue, and you can see all the places where it was the cold temperatures that allowed the Ottoman Empire to flourish, that big yellow blob up and in the northern part of there. It was the warm time that allowed Rome to be so proud, and so on. That geohistogram is available on the website right above the climate and history one, which is a clickable map about that graph. That graph, the one that links various points of history with these temperature changes. So we've got 4 websites that I will leave on the screen. And thank you very much. The end of this one.